Hello and a warm welcome to Chapter 3 of the Beginner's Guide to AI. In this chapter, we'll meet the AI family, focusing on machine learning as a central pillar, its various learning methods, and deep learning, which uses neural networks for complex problems. Machine learning, or ML, is a significant subfield of artificial intelligence. It's an approach where computer systems learn from data, identify patterns within that data, and then make decisions or predictions with minimal human intervention. The core idea is to let computers learn to program themselves through experience, instead of developers writing explicit code for every single possible scenario. They design algorithms that will allow machines to learn from examples. Now imagine trying to write a traditional program to recognize pictures of cats. You would have to define all possible cat features, pointer ears, whiskers, fur patterns, an incredibly complex task. Machine learning takes a different route. Show the computer thousands of pictures, some labeled cat and others not cat. The ML algorithm then analyzes these examples and learns the distinguishing features on its own. Once trained, it can identify cats in new pictures. Common examples of machine learning include recommendation engines, systems that predict stock market fluctuations, bank software that detects frauds, and applications that categorizes images. So, AI is the broad goal of making machines intelligent. This is the overarching field. Machine learning is a way to achieve AI by letting the systems learn from data. So, a subset of AI. Deep learning is a powerful type of machine learning using complex brain inspired networks. It's a subset of machine learning. As you can see, artificial intelligence is a broad overarching field. Machine learning is a subset of AI. It is one way to achieve artificial intelligence by letting systems learn from data. And deep learning is a specialized type of machine learning that uses complex, brain inspired networks. So the hierarchy is key. Deep learning is a specific technique within machine learning, and machine learning is one of the primary ways to build artificial intelligence systems. Supervised learning is one of the most common types of machine learning. In this approach, the AI model is trained on data that is labeled. This means the training dataset includes not only the input examples but also the corresponding correct answers or desired outputs. A helpful analogy is learning with flashcards or a teacher. Imagine teaching a child to distinguish between apples and bananas by showing them pictures labeled apple and banana. After many examples, the child learns to identify them. Similarly, an AI algorithm is fed data with explicit labels. For instance, to identify dogs in pictures, it would get images tagged dog or not dog. The algorithm learns the patterns associated with each label to make predictions on new, unlabeled data. Supervised learning is typically used for two main types of tasks. First, classification, which involves sorting items into predefined categories, like determining if an email is spam or not a spam. A specific type is binary classification, where there are only two categories, like yes and no. Second, regression, which involves predicting a continuous numerical value rather than a category, such as predicting the future prices of a house. Reinforcement learning, or RL, is another distinct approach where an AI model called an agent learns to make a decision by interacting with an environment. The agent takes actions within its environments and receives feedbacks as rewards, which is positive, or penalties, which is negative. The agent's goal is to learn a policy, a strategy that dictates which actions to take to maximize its total accumulated rewards over time. A simple analogy is training a pet. To teach a dog to sit, you give it a treat, a reward, for performing the action correctly. Over many trials, the dog learns which actions lead to rewards. Similarly, an RL agent learns through trial and error. Another analogy is a robot navigating a maze to find a diamond, getting points for good moves and losing points for bad ones. The RL agent often starts with little knowledge and might make random actions initially, but through repeated interactions, it refines its policy. Reinforcement learning is well suited for tasks involving sequential decision making in dynamic environments, like training AI to play complex games, teaching robots physical tasks, or developing control systems for self driving cars. The table on your screen offers a quick side by side comparison to help distinguish these three types of machine learning. So, supervised learning is like learning with a teacher using labeled data for tasks like spam filtering. Unsupervised learning is like learning on its own by sorting unlabeled data useful for customer segmentation. And reinforcement learning is learning by trial and error through interaction with an environment, like a robot trying to navigate. Deep learning is a powerful and specialized subfield of machine learning. It has been the driving force behind many significant AI breakthroughs, especially in understanding images and human language. The deep in deep learning refers to the use of artificial neural networks that have multiple layers, often many layers, stacked between the input and the output. These layers allow the model to learn complex patterns and hierarchical representations from vast amounts of data. The fundamental idea behind deep learning is inspired in a simplified way by the structure and function of the human brain. While current artificial neural networks are far behind matching the human brain's complexity, they attempt to simulate how interconnected neurons might process information to learn from experience. Artificial neural networks, or ANNs, are core computational models that power deep learning. They are inspired by the biological neural networks in animal brains and consist of many interconnected processing units called nodes or neurons, typically organized in layers. Here's a simplified overview of how a neural network typically works. First, the input layer receives the initial data, like the pixel value of an image. Between the input and the output are one or more hidden layers, where most of the computation actually happens. Neurons in these layers process inputs and pass outputs to the next layer. The depth comes from having multiple hidden layers. These layers enable the network to learn features at different levels of abstraction. For example, in image recognition, initial layers might detect edges, subsequent layers might recognize shapes, deeper layers might identify parts of objects like eyes, and finally, the network might recognize the entire object like a face. Finally, the output layer produces the result, such as a classification or prediction. The connections between neurons have associated weights, which are numerical values adjusted during training. By tuning these weights, the neural networks learns to map inputs to desired outputs. This automated feature engineering, where the network itself discovers relevant representations from raw data, is a significant advantage of deep learning. With that, we come to the end of chapter 3. Thank you for watching the AI with Arun show.